So I guess we can start. So many performance engineers today with us. Hello everyone. My name is Ola Kunysz. I came from Wrocław this morning actually, and I'll talk about performance. I think it's a really important topic for every developer, or rather software engineer, because we not only write code, but we really make software. All right, so as a developer, you probably know this moment when your client comes to you and says, I'm really not impressed. And it may happen like every day, or it may happen after some important change, performance-wise. For example, you sell magazines for fishermen, and one day someone says, no, we will sell sport clothes. And you sell 50 t-shirts per day, and one day Lewandowski scores, and everyone wants his t-shirt, and we have like 2 million in 2 minutes. So this may happen in your everyday work, and it's not your fault. It just, it happens. So performance is a continuous process. It's not something that you can plan at the beginning of the project. You have to be agile with that. So why am I talking about that? So I'm a software engineer since 2007. Most of the time I spent in JVM, but also I gathered the requirements, I tested, I taught new users. Since 2 years, I work in e-commerce, and in our industry, users don't forget and don't forgive. So if the performance is really bad, they won't come back. Because I'm not working in traditional e-commerce. For example, our customers don't go to Shopify or some other price comparison page and look for the best deals. They read magazines, they read articles, and they get inspired. And they want the product here and now. And if they have to wait a couple of seconds, it's gone. That moment is no longer with us. For some time, I was involved in Giger's Carrots and Code Carrots in Wrocław. And this is pretty much all about me. So let's talk about you and your awesome web app. So you used clean code. Your application is solid. It's a modern single-page application. You use all the hipster frameworks of this year. It's simply beautiful. So if there is an award of golden computer, you would probably get it. But honestly, nobody cares. Because if the screen loads 4 seconds, or it just feels slow, whatever that means, people just, leave without saying about the reasons. So you need to realize that performance is really a subjective topic. So if your mom uses Facebook, for example, probably her expectations are different than if you are a millennial and use Snapchat or Instagram, right? So performance is something good performance is something really subjective. But the good news for us as engineers is that you can still measure most of it. So where to start? You have roughly 2 ways where to go. To the rainbows at the front end, or to this madness of workarounds at the back end. How many of you do the front end on a daily basis? All right. What about back end? All right. What about full stack? Nice. So you probably will find something for you in this presentation, because I will try to cover both of the sides. So first tool that I highly recommend, and it's free, is a page speed from Google, the Insights. you simply type your address, and it shows you how your app is performing on the mobile and on the desktop. So this is how the meetup page, for example, is performing. So it is like so-so. But the funny thing is that page speed is also so-so. So they also need to do some improvements. And this is the example of the feedback that you may get about resources. And for example, here you have the optimization suggestions for the response time and for render blocking, and also for some resources that can be cached. So for each and every page, it will be different. We also have really modern tool. I guess everyone is using that on a daily basis, which is developer tools. Almost every browser or every browser has it. I really recommend you, when we talk about performance, that you try this setting of not using your Wi-Fi or your LTE, but instead trying to see how your application behaves on slow or fast 3G, and feel the same feeling that people who are scrolling through your website, like walking mountains or something. So this is really cool tool. And here you have the time of waiting, which means between the request is sent and the first byte comes back from the backend, and the download time, which means the data is coming. So if this blue bar is too long, it probably means that your payload is extremely big. We also have performance tool in developer tools. Lots of stuff going on here, but I want you to focus on the frames, because it shows what shows at each time point. So for example, here we have a meetup page, and almost 2 seconds are gone, and we still see the empty page. After a couple of milliseconds, we see more or less the most important stuff, so the titles and the names and some icons. Then after 2 seconds, we see almost all the informations except cookie, because you can see here that there is this black bar with cookies. So you see almost everything here after more than 2 seconds. For example, Devoxx page had different approach. So they decided to give us a loader for like 3 seconds or something, and then show everything at once. So you may decide what's better for you, for your user. Like I said, it's really personal, and it's really subjective. About monitoring, we may do load and performance testing, but this is when you already know that you have some bottlenecks. For example, you know that some of the endpoints on the API are pretty slow, or you are, for example, rewriting your code to improve the performance. Then you may use one of the tools. We use Gatling for some solutions, because writing those tests is really expensive. So you not always want to do that, and there's not always time for that. So for example, this is the example of the scenario. So you simply ask the REST to save the product for you, check if the status is okay, and get all the products 10 times. This is, of course, really simple solution, but you get the idea how it looks. And this is an example of the report. So all the green is good, which means it's below second, and all the red stuff is KO, which means you failed totally. If you don't want to use external tools, but you still want to know how your endpoints are performing, you may simply write a script. And this is an example of a script that I honestly use in my project, which gets all the products 10 times. So it instead of printing all the payload, it prints only the timing. So this is the example of the responses. So you can see that it varies. And this is really useful when you want to refactor your code and improve the performance there. So you benchmark the payload before and after your refactoring. And old but good JConsole for the JVM projects. And this is the true story, actually from last week, when I forgot about filter. On daily basis I write Scala code, and sometimes I forget about filtering, and my endpoint jumped from like 200 megs to almost 1 gig. So it was like, something is really wrong here, because I actually killed the application on dev environment, because the limit was, I think, 700 megs or something like that. So each time this endpoint was called, it completely crashed the application and the server restarted. So thanks to that tool, I was able to find the problem. And don't try to look for documentation, because thanks to Oracle, we have documentation like that. So this is probably the reason that no one is reading documentation anymore, because it says a memory displays information about memory use. Wow, thank you, Oracle, really helpful. So when you already know when the bottlenecks are, you may try to tune up your front or backend. So let's start with the front. I will show you the tricks to improve the performance on front end, or at least pretend that performance is better. So let's start with caching. Caching is mostly for static resources. We use CDN for that, which means Content Delivery Network. And the good thing about it is that data centers are across countries and continents, because you don't want your clients from US to download the static resources from Dublin, for example, because this is closest to your server. But you want them to download resources from US, right? From the best from the closest city. And also, it delivers locally for every user, and improves performance, as you can see on the attached image. This is the example of the Cloudflare. You also have the Amazon tools for that and other tools. I recommend you the StackShare page, where you can see the comparison of tools and their strong and weak points and who is using them. Really cool page. When we talk about caching, also let someone serve you the images, because you don't want to play with that anymore. It's not 90s. There's soft for serving the pictures. We use Cloudinary, for example. It serves us responsive and scaled images. You simply ask the REST for that. They also store the images for us, so we don't want to handle that on our own. And you may have the real-time manipulation of the pictures if you don't want to play with CSS, for example. And I absolutely loved these examples with happy animals. We don't use that, but those examples with ships just bought my heart. So I decided to show it to you. All right, the CSS and JavaScript. You all know probably that it should be minified, non-blocking, concatenated, and compressed, right? There are tools for that. We use Webpack, for example, so it all packs the bundles and dependencies to one file per each type. But there is a problem. It gets really big. So modern applications get really big. And to find where the most of the load is, you of course may look on your own, but you also may need the the external application. And this fancy stuff that you can see here, it's called Webpack Bundle Analyzer. This is a really cool tool that can be installed with NPM or Yarn that generates a JSON file for you, and from that JSON file, it runs the interactive map on your local host. And it visualizes the content of your bundles, so you can easily see, click, and check if it's zipped or parsed or whatever. And dynamic import, which means you split the modules into categories, into small chunks that are downloaded not per rows, but instead per modules on demand or conditionally. So for example, preload means that you may need that component in the current navigation. You may program that in your code. So say, give me that when I need it. Or you may use tools for that. For example, Webpack does it for you. You just simply change the configuration of the Webpack in a project. And prefetching is really interesting idea because this means that you will need that in the future. So if you are, for example, on the product page and you hover on the Add to Cart button, you will probably need the shopping cart view as a next step, right? Or checkout. So you can prefetch the resources that you will need in the future, but not the whole heavy application, but instead the small chunks. And let's move now to the appearing faster instead of being faster. So content placeholding is used, for example, by Facebook or other applications. And it means that you download the minimal file that can be presented to the user, and it appears that something is loading, right? So even if you are almost offline, you still see something. You remember the meetup page when we saw some just frames and with some labels here and there. So this is what they do. They do the placeholding, and we also use that in our project for the shop view. So at some point, our shops got really big, and the performance was getting worse and worse. So we decided that we may preload the image of the shop and the list of collections, at least first collections, and to draw some kind of frame for the shop. And then we download the rest of the data and fill the shop with real products and names. And optimistic updates is really something something that you may try, but only if it makes sense. Because if you're in banking sector, for example, I don't recommend you that because it's optimistic, because it doesn't care if the server responses with OK. It just shows you the optimistic scenario. So it says, OK, it was added, it was sent, it's fine. But sometimes the request fails somewhere on the back end. We don't want that, but sometimes it happens. And if you need the security, it's probably not the way to go for you. So for example, here again, with the Facebook, if you send the message to your friend and you hit save button, but you're offline, you still can see that the message was sent. It was not really sent, somewhere in the middle, but if you refresh the page, it will disappear, right? So we use the same logic for favorites, for favorite products. So if you hit the heart, you will see that the heart is red immediately. But if something happens with the request and you refresh the page, it won't be there. So your product won't be added to favorites. But since it's not so critically important, then we may use that optimistic update for this scenario. So this is all about the front-end hacks. Let's talk about the engine of the application, the backend. So First of all, REST and paging of the request. So probably the most common one, skip and take. So you only take some bunch of products or of other resources. And I tested that on some random request. Took 200 milliseconds, which is pretty nice. But for 1,000 products, it took 6 seconds. So you can see that it's huge difference. And this is Wi-Fi. For fast 3G, it took me 700 milliseconds to get only 20 products. And I didn't even try to get 1,000. Because, yeah, I didn't want to get mad. But please don't use paging on the front end. Use paging in REST, and then use lazy loading on the front end. Not only because it's the killer of your conversion, but also because it's just bad user experience. Sending only the necessary information, which means cutting the payload, is also something that you should consider. For example, you can see here the view of the product in the collection view. So you only need the one picture, you need the name, you need the price. And the payload for that is 10 kilos for 20 products. But here on the right, you can see that there is lots of information about this product. So you have all the images, you have all the sizes, the price, the description, etc. And this payload is 3 kilobytes. Because we don't download images, we simply send links via REST. So you can easily see that it would take 6 times more to get 20 products with this payload. Consider excluding expensive data to additional endpoints, whatever expensive data means to you, because it's different for every project. For example, for us, product availability is something which is expensive because we take it from third parties sometimes, and it's not so important when you scroll through collection view, but when you do the checkout, you better have this information, right? So that's why we use different endpoint for that. So we take the products as one endpoint, and then when we need the availability information, then we get it. Because it's better for one person who is adding to cart to wait for another request than to make bad performance for every single user of your application. gzipping is also something really popular. It has some cost of encoding and decoding on the front end, but it also speeds up the performance. And caching on this level, because we talk about caching in CDNs, and caching for REST is also something interesting. We are thinking about that right now in our project. So you may use the dates or you may use the token. At least those two ways there are to go. But also there are some other solutions. Databases. This is the huge topic. Probably we could make another presentation out of it. So indexes, for example, for expensive or common requests. And if you are a Mongo user, how many of you use Mongo? Not so many. Interesting. Anyway, there is a tool called Performance Advisor for MongoDB, and it shows you which endpoints are slow or which endpoints can be tuned up or improved. And if you click this More Info button, it shows you the script that can be copied to the database directly. So probably there is some tool for your database like that as well. Data duplication is a really interesting topic. It's hot, especially if you deal with microservices, because when you get most of the information, so you read more often than you write, it's probably the good solution. when you have the resources, the same resources everywhere. So for example, for us, there is this product, and product is everywhere. So we use product in collection, we use product in checkout, we use product in the shopping cart. So if we simply have the microservice for product and only the data about product is only there, then we would get the hell of REST communication there. So probably the data duplication is a good solution here. Sorry. And performance is important I mean, if your performance is more important than consistency, then probably data duplication is also a good solution for you. But it's your own decision, because it's not free. If you duplicate the data, you need to synchronize it, and you may get inconsistent at some point, so it's really up to you. So here's the plan. First, observe and measure, because it's your application, you know how it should behave, you know what's wrong there, where to look for bottlenecks, and how to make your customers happy, because it all depends on the group that you're selling to or you're creating your software for. Then find the bottlenecks, either on the front end, on the back end. It could also be the DevOps, but this is also the topic for another presentation. Fix a little bit. Don't stop the development for 2 months and say, hey, now we are working on the performance. The whole team is out of development because we are improving performance. No, just fix a little bit. Fix one endpoint, make benchmark first, see if you are improving anything or you just think that you are improving that. Don't trust your gut. Look for numbers, measure everything, and, repeat. Make this continuous process, because performance is our common deal. We don't have performance engineers in the projects, do you? Any of you have performance engineer full-time? I don't see any hands. So, there's one hand, sorry, 2 hands. But most of the projects don't have performance engineers, so all the backenders and all the frontenders need to take care of that. And this is the constant process. Like I said at the beginning, when the requirements are changing, performance requirements will also change. So repeat that in time, and you'll be fine. Thank you very much. I hope it was helpful for you. And